everyone! Today we're gonna see about Multilayer Perceptron. Here is the objectives. Non-linear separable data, Multilayer Perceptron, Python implementation of Multilayer Perceptron for non-linear separable data, result of the Python code implementation, application of MLP, that is Multilayer Perceptron. Non-linearly separable data. A non-linearly separable data refers to a type of data distribution where the classes or categories are not linearly separable in the input space. In other words, there is no single straight line, plane or hyperplane that can perfectly separate the data points belonging to different classes. For example, imagine a data set where the points of one class are arranged in a circular pattern surrounded by points of another class. No straight line can divide the classes perfectly. Similarly, in three-dimensional or higher dimensional space, the boundary between classes might be curved or irregular, making linear separable impossible. Multilayer perceptron. In multilayer perceptron is a type of artificial neural network that consists of multiple layers of nodes or neurons that are arranged in a feed-forward manner. Each neuron in one layer connects to every neuron and the next layer without forming cycles. Multilayer perceptrons, there are three different types of layers. One is input layer. It is the first layer of the network which receives the input data. Second is hidden layer. In hidden layer, it will intermediate layers between the input and output layers, and these layers contain neurons that perform nonlinear transformations on the input data. And the final layer of the network is output layer, which produces the output prediction or classification, applications, and perceptron structure. Multilayer perceptron find applications in diverse fields such as image classification, natural language processing, and speech recognition. They excel in pattern recognition, task, financial forecasting, and robotics. The ability to learn complex relationships in data. MLPs are also utilized in anomaly detection, signal processing, and control system, showcasing the versatility across various domains. Python implementation. Here are the overall steps in this code. Let's see. First is setup, initialization, forward propagation, backward propagation, training loop, plotting loss, prediction, and testing. Let's see the Python code implementation. In first step, we input necessary libraries like NumPy for numerical computation, Pandas for data manipulation, IO for input-output handling, and matplotlib.pyplot has plot for plotting graphs. We define the input data x and output data y. And for some parameters like the number of input units, n underscore x, number of hidden units, n underscore h, number of output units, and n underscore y learning weight, that is LR, and number of training example is m. Now, initializing. We initialize the weight W1 and W2 randomly. These are the parameters that the model will learn during the training. Next, forward propagation. We define a sigmoid function that converts any input into value between 0 and 1. We implement the forward propagation process which computes the output of the neural network given the input data and current weights. Now, and the next step is back propagation. We implement the back propagation process which calculates the gradient of loss function with respect to the weight. This step is crucial for updating the weights in the directions that minimizing the loss. Next is the training loop or iteration. We run a loop for a certain number of iterations or epochs. In each iterations, we perform forward propagation, compute the loss, perform backward propagation to get the gradient and update the weight using gradient descent. Now, Plotting loss. After training, we plot the loss over epochs to visualize how that decreases over time, and this gives visualize how well the model is learning. Now finally, we define a function that predicts the weights and the training model, and we also give one year new input data points. Next is the training twist, the training model by providing here with different inputs combinations and print the corresponding predicted outputs. Therefore, here is the overall. This program demonstrates the implementation of simple neural network using NumPy for binary classification task. It learned to predict the output Y based on the input X, a series of forward propagation steps. Let's get into the last topic of applications. Classification. MLPs are frequently used for classification tasks where the goal is to categorize input data into predefined classes or categories. This includes applications such as image classification, where MLPs can learn to distinguish between different objects or scenes depicted in images. Regression. MLPs can be used for regression tasks where the goal is to predict a continuous value rather than a category. For example, MLPs can be employed to predict housing prices based on features such as location, size, and number of rooms. Pattern recognition. MLPs are adept to recognizing patterns in data, making them suitable for tasks such as speech recognition, handwriting recognition, and biometric identification. Time series forecasting. MLPs can be applied to time series data to make predictions about future values based on past observations. This includes applications such as financial forecasting, weather prediction, and demand forecasting in supply chain management. Thank you for listening this video.